Oh god!
Did you know that the bell-shaped nozzle that is the most recognizable feature in rocket engines was actually invented in the 18th century by a Swedish engineer to power steam turbines? Did you know that the V2 rocket, the first long-range rocket to be used in war, used steam turbines to pump propellant into the combustion chamber at high pressure? Also, did you know that to this day, the majority of electricity in the world is still produced using steam turbines? My point with all of this is to say that steam turbines are pretty useful, and also pretty cool. I would like to build one, and I think I can 3D print it. You see, with normal FDM printing, especially if you're using PLA plastic, the parts start forming at 60 degrees Celsius and melting at 150 degrees Celsius. Lately I've been experimenting with resin 3D printing, and one of the cool features of resin is that it doesn't really melt, but instead ablates, which basically means it keeps its shape. Now, 3D modeling and 3D printing a steam turbine is pretty easy. I can do it in less than 2 hours, but if I want to test a steam turbine, I'm gonna need some steam. A few videos ago I bought some resistive wire that goes incandescent hot when you pass a current through it. Using an acrylic tube and some 3D printed parts, I created an improv steam chamber. I attached some of that wire to 2 M3 screws and I filled it up with water. Using a temperature sensor, I measured that the water was reaching about 60 degrees Celsius, which might be enough to prepare some ramen noodles, but is not the solution that I need to get high pressure steam.
Oh, the steam engines that were used in the locomotives in the 18th century used boilers to generate steam. So good.
The closest thing that I can easily get that resembles a boiler is a pressure cooker, so I got one and I equipped it with a manometer to measure the pressure. To make sure the steam came out at the desired speed, I 3D printed a nozzle in resin. I attached the vinyl tube to the cooker and connected it to the nozzle. I poured some water into the boiler and used an electric stove to get it steamy, and once things were at the best temperature, I actually got what I wanted: steam. Do you guys remember how I said I could 3D model and 3D print a Pelton turbine in less than 2 hours? More like 2 days. In my first iteration, I 3D printed a resin turbine with a fast locking mechanism. That seemed like a good idea at first, but it was very unstable and caused too much friction. My next genius idea was to 3D print a hub in PLA and individually print each bucket of the turbine in resin, which I later had to manually glue to the hub. Now, I don't think I need to tell you why this was a bad idea. It was a lot of work and totally not worth it.
The screw is not well screwed. Oh right, so this is rotating in the direction in which the screw unscrews. That's not gonna work. I'm gonna have to fix that.
After that failure, I got back to the computer and I redesigned the turbine to be printed in one go, all in resin. I attached it to a PLA support and I first gave it a test with compressed air. That's a lot of speed! If the turbine worked with compressed air, it should also work with steam, so I assembled the nozzle close to the turbine and I turned on the stove once more. It's working! It's working! Come on, Stevie boy!
Oh god! Look at that!
So fast! That's amazing!
Can I stop it?
Now, it's pretty cool that the turbine is spinning that fast with just the steam coming out of a pressure cooker. And the added bonus is that my theory was correct. The resin can handle the temperature. But the truth is that we call it steam power and not steam speed, which means I needed to test it for force. And to do that, I used an apple.
Nothing happened.
To get more torque, I could use gears or optimize the nozzle to get more speed. I could, but that's not what I did. A few videos ago I discovered a reaction that turns hydrogen peroxide into steam. And when I say it turns it into steam, I mean it generates insane amounts of it.
Jesus Christ! Oh my god.
This is actually the reaction used in the V2 rocket that I mentioned in the beginning of the video to generate steam and power the turbines. I already made a video where I built a rocket engine using this concept, but I never really explored it into a design that generates steam for a turbine. So for this project, that is exactly what I did. The reaction itself uses hydrogen peroxide and a catalyst, so to make the steam generator I needed to pump the hydrogen peroxide through the catalyst, that in this case will be manganese dioxide. To pump the peroxide I used a 100 ml syringe that I cut using a banana. As you can see, the banana didn't really cut all the way through, and that's because the banana wasn't ripe enough. It's important to use good tools. Next, I cut a 10 cm piece of acrylic tube, this time using a better banana, and as you can see, I got a much cleaner cut. To hold the catalyst I used a steel wool that I impregnated with manganese dioxide. To join everything together, I used some resin adapters. In between the two chambers I placed a one-way valve to make sure the high pressure wouldn't push the steam backwards into the syringe again. To measure the pressure I placed a manometer on the reaction chamber, and to insert the peroxide I inserted a manual valve on the syringe. After filling up the syringe with hydrogen peroxide, I mounted the turbine in place and gave it a test.
3, 2, 1. Wow! Jesus Christ. The turbine is all black. Look at this! Let's try it again.
I did some more tests, but it got to a point where the pressure was pushing the catalyst out and making a mess. This design can obviously be improved, and I have some ideas. One of them is to use a catalyst that can be melted and casted into a mesh, like silver. Another one is taking the powder catalyst and mixing it with resin, so I can 3D print the mesh directly in the 3D printer. What do you guys think? In the future I might be able to turn this concept into a full-blown rocket, or at least use it to power the pumps. As you can see, it's possible to stretch 3D printed parts to the limit of their use, but you can only do that if you have a 3D printer, and if you don't, well, let me help you with that. On my last video I gave away 3 3D printers to the most liked comments suggesting a theme for a future video. If you also want to win a 3D printer, all you need to do is subscribe to the channel, leave a like on this video, and post a comment suggesting a theme for a future video. The most liked comment will receive a brand new 3D printer. Well, this is everything for today. Thank you so much for watching, and remember, tomatoes are disgusting. See ya!
Hello, this is Intaxa trying to discover if there's too much reverb, if there's background noise.
Yep, that's crap.
Look at this one. Oh.